All right, now let's do question 4. For question 4, we are given a table of values for y equals to x cubed over 5 minus 2x plus 1. So in part A, for x minus 4, we just have to sub this value into the equation, and that will give us minus 3.8. So in part B, we are expected to draw the graph of y equals to x cubed over 5 minus 2x plus 1 for x between minus 4 and 4. So for this part, I've already drawn a graph. So some pointers, right, is that you have to make sure that all your points are properly plotted onto the graph itself. Okay, and make sure that your curve is smooth. Okay, and that's it for part B. And now for part C. So they tell us that the equation x cubed over 5 minus 2x plus 1 equals k has two solutions. And we have to use the graph to find the two possible values of k. So when it comes to this kind of questions, right, where they give us an equation and they tell us how many solutions there are. So in this case, it has two solutions, right? So we can look at the graph, okay, and we have to plot the line of y equals to k. Okay, so as you can imagine, y equals to k. So for this line y equals to k, right, it only has two solutions, which means, right, that, okay, let me just draw this line out first. Which means that the line y equals to k can only intersect the curve at 2 points. It cannot intersect the curve at 1 point and cannot intersect the curve at 3 points or 4 points. So example, in this case, it only intersects the curve at 1 point, so this is not a solution. But then if I bring it down to this point, okay, can you see that the line only touches the curve at 2 points? So we have this point over here, as well as this point over here. Okay, so this is one of the solutions. So for this, we have our solution to be y equals to 3.4. Now we have to find the next solution. Okay, so if you break down the curve to this point, okay, let me just draw a straight line. Okay, we can see that actually over here, right, the line intersects the curve at not just 2, but we have 1 point here, 1 point here, another point here. So it's 3 points. That means that is not the solution for k. So instead, let's bring this down all the way to this point. So as you can see here, there's only two intersections. This point here and this point here. So that means, right, our solution for this is y equals to minus 1.4. Okay, so the answer is k equals to 3.4 or k equals to negative 1.4. Okay, then moving on to part D. They say that by drawing a suitable straight line on the grid, solve the equation 2x cubed minus 25x plus 20. So what do they mean by drawing a straight line on the grid? Like what straight line, right? Where's the straight line? Okay, so the straight line is something that we must derive from this equation. So how do we derive the straight line from this equation? The first step is to transform transform the equation transform 2x to the power of 3 minus 25x plus 20 equals to 0 to resemble the equation that is for the curve, okay, which is x to the power of 3 over 5 okay, we just have to resemble this particular equation. Now, the first step to doing that is to ensure that the x with the highest power have the same coefficient. So you want to make sure that this and this have the same coefficient. So let's take a look. So actually we can divide we can divide this by 20. Okay. Divide by 20. So that we will get, sorry, not 20, divide by 10. So that we will get the similar equation. So x to the power 3 over 5 minus 5 over 2x plus 2 equals to 0. Okay, can you see that it somewhat resembles this equation? Okay, somewhat. Now you have to go and break this down further. Okay, so we can do that by okay, we just write x to the power 3 over 5 minus 2x over here. Okay, so you have to, since over here we minus 2x, right? We have to add 2x back into this. So that will give us, okay, so what I mean is minus 5 over 2x plus 2x. Okay, so then for the, okay, then you want to transform this into 1. So over here, right, plus 1. Okay, since we plus 1 here, that means we subtract 1 from 2, so we're left with plus 1 equals to 0. So we just rewrite this into x to the power of 3 over 5 minus 2x plus 1. Then the remaining, we have minus half x plus 1 equals to 0. So we make the x to the power of 3 over 5 minus 2x plus 1 on the left-hand side. And we shift the rest, which is half x minus 1 to the right-hand side. Okay, so now we actually have our straight line equation, which is half x minus 1. Okay, so this is something that we can plot on the graph itself. But first, we want to go and make our table. Okay, so when x equals 2, we take the extreme limit, so it's minus 4 and 4. Minus 4, 4, and then 0 in the middle. When x equals to minus 4, y equals to minus 3. Then minus 1 and 1. Okay, so we plot this on the graph itself. Okay, let me just erase the previous. Yeah, okay. So x minus 4, y equals to minus 3. And then x equals to 0 and y equals to minus 1. And finally, we have x4 and y1. Okay, so this is a straight line that is cutting across the curve in this manner. Okay, something like this. So we can see that we have 3 solutions to the equation. Okay, so the points are this over here. Okay, where okay, for this point, your x is around minus 3. Okay, according to my graph, your x is minus 3.7. Okay, note that we're only concerned about the x values. Okay, because we want to solve for x. Then for this point, okay, for this point, right, our x is about 0.8. And lastly, for this point, our x equals to 3. Okay, note that your points may be slightly different from mine because of the way the graph is plotted on because of the way the graph is printed on my iPad. Okay. But anyways, your value should be x equals to minus 3.7 or 0.8 or 3 or anywhere that is close to these numbers is acceptable as well. Okay, so that is it for question 4.